Now, under the topic called exponents and powers, so we are going to discuss laws of indices. So, under this topic, we are going to discuss the various laws, that is 9 in number, which has product law, quotient law, and similarly and so on. So, first of all, let us discuss about the law number 1, which is the product law. So, under this product law, first of all, we will assume 3 positive integers, one as a, the second one as m, and the third one as n. Now, if a comma m and as well as n are 3 positive integers, then we have, say here we will be getting, say here, a power m into a power n is equals to a power m plus n. So, this will be called as the product law, in which a power m into a power n is on LHS, that is the left hand side, and the resultant, that is a power m plus n, is on the right hand side. So, here left hand side quantity is a power m and into a power n. The first exponential form is of a power m and the next exponential notation is of a power n. So, these two exponential notations are here multiplied here. Whereas, in the first case, that is the base is of a, and in the second exponential notation also the base is of a. That means, the bases are same in the LHS, on the LHS side, and the symbol in between is of multiplication. The fundamental operation between the two exponential notations is of into, that is the multiplication symbol when the bases are equal and the symbol in between is of into. So, we have to add up the exponents, that as m and n must be added. So that the resultant will be of, since bases are equal a and a, then the base will be of a, then we have to add up the exponents, since the symbol in between is of into. So, m and n must be added. So, we will be getting as the exponent as m plus n as the resultant. So, here let us perform one of the example under this product law, that is a power m into a power n equals to a power m plus n. So, here simplify (5 power 4) into 5 power 2. Now, the solution starts now. As per the problem, so we have to multiply 5 power 4 and 5 power 2. As per the problem, 5 raised to the power of 2 into 5 raised to the power of 2 is given for us. So, we have to simplify this form. So, in order to simplify this form, so here 5 power 4 into 5 power 2 is in the form of a power m into a power n, that is in the product form, that is the product law. So, if we can apply the product law, so here in order to multiply or in order to simplify 5 power 4 and 5 power 2, say here the bases are equal here, that is 5 and 5 each, and the exponents are of one is of 4 and the other is of 2. So, here as per the product law states that a power m into a power n is equals to a power m plus n. By utilizing this product law, now let us write the exponential notations which are given for us. One is 5 to the power of 4 into 5 to the power of 2. Whereas, when we compare 5 power 4 into 5 power 2 with the product law, so here a is of 5 in both the cases and m is by 4 and n is replaced by means of 2. So, here at a is equals to 5 and m is equals to 4 and n is equals to 2, say that the resultant will be of a to the power of m plus n, whereas a value is of 5. So, 5 to the power of m and n must be added. So m value is of 4 plus n value is of 2. So here 5 power 4 into 5 power 2 is equals to, bases are same and into in between, you have to add up the powers. So you have to add up the exponents. So 5 power 4 plus 2, then that equals to 5 to the power of 2 is of positive and 4 is of positive. You have to add up, since positive plus into plus is of plus, so you have to add up what I say 4 and 2. 4 plus 2 is of 6. So you have to assess the sign for the 6. Among 2 and 4, 4 is greater, its sign is of positive. So here need not write here positive, therefore 5 power 6 is the resultant. So here hence 5 power 4 into 5 power 2 is equals to 5 power 6 is the result. Then now, so here this is the law number 1, which is the product law. Then now let us go for the next law, that is second law. Law number 2, which is the quotient one. So quotient law. So under this quotient law, here also let us assume 3 positive integers, one has a, the second one has m, and the final one that has the n. If a comma m and n are 3 positive integers, then we have 2 cases here, that is case number 1. Under the first case, a power m divided by a power n. This is the first exponential notation by utilizing a and m integers, and by utilizing a and n integers, say here the next exponential index form is of a power n. So here a power m divided by a power n is equals to a to the power of m minus n is the resultant. So this is only possible, a power m minus n is only possible if numerator's exponent, that is m, is greater than the denominator's exponent, that is n. That means m must be greater than n. So then only this case is possible, that is the first case. So a power m divided by a power n is equals to a power m minus n. So numerator's exponent, that is m, must be greater than the denominator's exponent, that is n, n's value. M's value must be greater than the n's value, then only so here we will be getting the resultant as a to the power of m minus n. Then as the case number 2, in case number 2, a power m divided by a power n is equals to 1 divided by a to the power of n minus m. So this is possible if denominator's exponent, that is n, is greater than the numerator's exponent, that is m. So that the resultant will be of 1 divided by a to the power of n minus m. So here n minus m, m is lesser than the n, or in other words n is greater than m. So here denominator's exponent, that is n, must be greater than that of the numerator's exponent, that is m. Then only the resultant will be of 1 divided by a power n minus m. So here let us perform. So here examples under this. So example number 1. Simplify 7 to the power of 5 overall divided by 7 to the power of 3. Now solution starts. So here as per the problem, the given form is of 7 to the power of 5 divided by 7 to the power of 3. As per problem, we have 7 to the power of 5 overall divided by 7 to the power of 3. But here the base in the numerator is of 7 and the base in the denominator is also of 7, and it is of division symbol. So it will come under the quotient law. So numerator's exponent is of 5 and the denominator's exponent is of 3. That is, numerator's exponent is greater than the denominator's exponent. Therefore, the first law is applicable. That is, first case is applicable under the quotient law. So a power m into a power n is equals to a power m divided by a power n is equals to a power m minus n is applicable. So here in this case, so 5 is greater than 3. So 5 exponents numerator's exponent is greater than the denominator's exponent, that is 5 is greater than 3. So here now you can utilize the first law. Under quotient law, the first one, that first condition is a power m divided by a power n is equals to a power m minus n. So whereas here m is greater than n in this case, so we can utilize this law to simplify 7 to the power of 5 divided by 7 to the power of 3, then that is equals to, whereas here a is of 7 in the numerator and similarly a is of 7, we can write a as 7, then now here m value is of 5 and n value is of 3, then that is equals to a to the power of m minus n, whereas here 7 is 5 is greater than, so 5 is greater than 3, since m is greater than n, we can apply this formula, that is a to the power of a is of 7 to the power of m minus n, so here 5 minus 3, then that is equals to 7 to the power of 5 minus 3 is of 2, because here 3 is of negative and 5 is of positive, so plus into minus is of minus, we have to subtract, so here 5 minus 3 is of 2, among 3 and 5, 5 is greater, its sign is of positive. So in this manner, say here I got, therefore 7 to the power of 5 overall divided by 7 to the power of 3 is equals to 7 to the power of 2 is the resultant. Then now let us perform one more example, that is second one. For the second case, simplify 5 to the power of 3 overall divided by 5 to the power of 5. Now solution starts now. So here as per problem, we have 5 power 3 overall divided by 5 power 8. So 5 power, let us write it as 8. 5 power 3 divided by 5 power 8. So here denominator's exponent is 8 and the numerator's exponent is 3. Denominator's exponent is greater than 8 is greater than 3, that is 8 greater than 3. Denominator's exponent is greater than the numerator's exponent, so we can apply, since denominator's exponent, that is n is greater than m, we can apply the second case under the quotient law, that is a power m divided by a power n equals to 1 by a power n minus m. So here we can apply that formula. So here a power m overall divided by a power n is equals to 1 divided by a power n minus m. So this is possible unless and until this denominator's exponent n is greater than m. So by utilizing this formula, this law, we can simplify the problem which is for us, that is 5 power 3 divided by 5 power 8, 5 power 3 divided by 5 power 8. So here basis of a in the numerator and the basis of a in the denominator, whereas here 5 and 5 we can write, I say here a as 5, m value is of 3 and here n value is of 8. By substituting, so we will be getting it as, that is equals to, say here 8 is greater than 3, that is n is greater than m. So when n is greater than m, we can apply this formula as 1 divided by a to the power of a value is of 5 to the power of n minus m, n value is of 8 minus m is of 3, that is equals to 1 divided by 5 to the power of 8 minus 3. 8 minus 3, 3 is of negative and 8 is of positive here. So plus into minus is of minus, let us subtract. So greater minus least, that is 8 minus 3 is of 5. Then among these two 8 is greater, its sign is of positive, need not write here. So here therefore 5 to the power of 3 divided by 5 to the power of 8 is of 1 divided by 5 to the power of 5, which is nothing but the resultant. Then now